And then for second order, this will be your x, and this will be your y over here, sorry. And so that is second order. So what you're going to do is a linear regression of each of those, and you will need to look at the diagnostic, which is the correlation coefficient. So when you put that into your calculator, you do the linear regression, it's going to come up and ask you like what should be your x, what should be your y, and we just went over that. This tells you what should be your x and y for each order. And then you hit calculate, and it will give you a whole set of things. It'll say a equals this, b equals this, and then it should say like r squared and r. If it does not give you the r squared and r value, what you need to do is hit second 0, which should take you to the catalog. Go down to the D's to diagnostic on and hit enter twice. When you do that, then go back and redo the linear regression, and this time it should give you the r values. So what does this tell you? Well, in the calculator, it actually takes the form y equals ax plus b instead of mx plus b. So that means this is the slope and this is the y-intercept. And then the correlation coefficient, essentially what this tells you is how good it correlates into a line. So for instance, the closer this number is to 1, the closer it is to a perfect line. So you want like 0.9999, as close as you can. Sometimes you'll get like the first order having a 0.998, but then the second order will be 0.999. You always have to go with the one that's closest to 1. That means it's a better line. Some of your data might fit a different order decently, but you have to go with the best one. So once you figure out which one is closest to that, use that slope and that y-intercept, and you now have your equation. So let's say that the data fits perfectly. You get like 0.99999 for the first order equation. What that means is that you will go ahead and, if you're writing out the integrated rate law for that equation, you would say the natural log of the concentration of A at time t is equal to, and it will give you the slope, and when it pops this slope out, that is negative k. So A times t, okay, because A is equal to negative k, plus whatever it gives you for B, all right? And remember, B is equal to the natural log of A0. It's not that B is the concentration of A initially. B is equal to the natural log of A at time 0. So, if it wants to know the rate constant, well, in this case, A is equal to negative k. So you would have to take the opposite of A, and that would be your rate constant. That's the same for 0 order. For second order, A is equal to k. You don't have to do any of that switching. I know that's a lot, and I'm sorry about that. Hopefully it helps out a little bit, though, and this will help get you ready.